There are now two serious open source AI coding agents fighting for the terminal, and picking the wrong one could mean rebuilding your entire workflow later. One of them ships with everything you could want out of the box. The other ships with almost nothing and argues that's exactly the point. Today we're putting OpenCode and Pi head to head, so by the end of this video, you'll know exactly which one belongs in your terminal. Let's start with what these tools actually are, because they solve the same core problem in fundamentally different ways. Both OpenCode and Pi are terminal-based AI coding agents. You run them in your terminal, they connect to large language models like Claude or GPT, and they can read your code, edit files, run shell commands, and have extended conversations about your codebase. Think of them as open source alternatives to Claude Code. Both are written in TypeScript, both are MIT licensed, and both support over 20 LLM providers. But that's roughly where the similarities end. OpenCode was built by the creators of Terminal.shop and a community of NeoVim enthusiasts. It takes what I'd call a batteries-included approach. Out of the box, you get a multi-agent system with specialized agents for different tasks, a built-in permission system with approval dialogues, language server protocol integration for code intelligence, full model context protocol support for connecting to external tools, a SQLite database for session persistence, and even a Atari-based desktop app alongside the terminal interface. OpenCode's philosophy is that a coding agent should work well immediately with sensible defaults and deep integrations. Pi, created by Mario Zechner, takes the opposite approach. Its philosophy is stated clearly in the readme. Pi is aggressively extensible so it doesn't have to dictate your workflow. Pi deliberately ships without sub-agents, without MCP support, without a permission system, without plan mode, and without built-in to-do tracking. Instead, it provides a powerful extension API and says, build exactly what you need or install a community package that does it your way. The core stays minimal. Everything else is opt-in. So these two projects represent a genuine philosophical split in how developer tools should be designed. Let's dig into the technical details of each one, and then we'll compare them directly. Starting with OpenCode's architecture. OpenCode is a monorepo with around 21 packages. The core engine lives in a single package, but there are separate packages for the web console, the desktop app, the TypeScript SDK, the plugin system, shared UI components, and documentation. Under the hood, it runs on Bun, which is significantly faster than Node for startup and execution. For its LLM abstraction layer, OpenCode uses the Vercel AI SDK version 5. This is a well-maintained, widely adopted library that provides a unified interface across dozens of providers. The practical benefit is that OpenCode inherits provider support almost for free as the Vercel SDK adds new integrations. One of OpenCode's standout features is its multi-agent system. It ships with several specialized agents. The build agent is the default, a full-access development agent that can read, write, and execute anything. The plan agent is read-only, designed for exploring and analyzing code without making changes. It can only write to a specific plans directory. The Explorer agent is a fast, lightweight specialist for codebase navigation, restricted to search and read operations. And there's a general agent for complex multi-step tasks that acts as a sub-agent. Users switch between these agents with the tab key, and each agent has its own permission rule set. You can also define custom agents in your configuration file, specifying which model they use, what permissions they have, and what their system prompt says. For data persistence, OpenCode uses SQLite with the Drizzle ORM. Sessions, messages, permissions, and MCP credentials all live in a single database file. This is a meaningful architectural choice. SQLite gives you transactional integrity, efficient querying across sessions, and a single file that's easy to back up. OpenCode runs it in WAL mode for better concurrent read performance. OpenCode's permission system is layered and granular. Every tool invocation goes through permission checks. You can set rules per tool and per file pattern. For example, you might allow all file reads, but require approval for editing.nvm files and completely deny shell commands that touch production directories. Permissions cascade through multiple configuration levels, from global user config down to project-specific overrides. When the agent needs approval, it shows an interactive dialog right in the terminal, and you can choose to allow once or always allow that action. The MCP integration is full-featured. OpenCode can connect to both local and remote MCP servers, supports STDO and HTTP transports, handles OAuth authentication for remote servers, and automatically registers tools from connected MCP servers. If you're already using MCP servers with other tools, OpenCode will work with them immediately. Another notable feature is built-in LSP support. OpenCode can spin up language server protocol servers for TypeScript, Python, Go, Rust, and other languages. This gives the AI model access to real code intelligence like hover information, go-to definition, and symbol references rather than relying purely on text pattern matching. It's a subtle but meaningful advantage for code understanding accuracy. OpenCode also has a skill system that's compatible with Claude Code's skill format. Skills are markdown files with front matter that define specialized behaviors. And there's a plugin system based on NPM packages that can hook into nearly every part of the lifecycle, from configuration, loading, to message transformation, to tool execution. Now let's look at Pi's architecture. Pi is also a mono-repo, but with a different structure. The key packages are the coding agent itself, PyI for the LLM abstraction layer, PyAgent Core for the stateful agent runtime, and PyTui for the terminal rendering engine. There's also PyMom, a Slackbot companion, and PyPods for GPU deployment. The most significant technical decision in Pi is that it built its own LLM abstraction layer from scratch, instead of using the Versailles ISDK. PyI is a unified multi-provider LLM API that supports 30-plus providers, including some that the Versailles SDK doesn't cover, like Minimax and Kimi. Building their own layer gives the Pi team full control over streaming behavior, tool call parsing, and provider-specific optimizations. The trade-off is maintenance burden, but it also means Pi can implement features like partial JSON parsing during tool argument streaming exactly the way they want. Pi session management uses a JSON-L format, which is a flat file where each line is a JSON object. Every entry has an ID and a parent ID, which enables a tree structure within a single file. This is clever. It means you can branch conversations, navigate the full history tree, and jump between branches all within one file that's easy to inspect with standard Unix tools. The tree command lets you visualize your entire conversation history and navigate to any point. The fork command creates a new branch from any message. It's genuinely one of the best conversation management interfaces I've seen in a coding agent. Pi's extension system is where the philosophy really comes alive. Extensions are TypeScript files loaded directly by Jitty, so there's no compilation step. An extension can register custom tools, commands, and keyboard shortcuts. It can subscribe to lifecycle events like session, start, agent start, tool calls, and model selection. It can interact with the user through confirm dialogues, select menus, and text input prompts. It can even render custom TUI components. The extension API gives you access to the session manager model registry, auth storage, and event bus. In other words, extensions can do essentially anything the core can do. This is where Pi's opinionated omissions start to make sense. No built-in permission system? Write an extension that shows a confirm dialog before dangerous commands. No subagents? Spawn Pi instances via tmux or write an extension that coordinates multiple agent loops. No MCP? Build a skill with a CLI tool and a README, or write an extension that adds MCP support. No plan mode? Write plans to markdown files, or build an extension that manages plans however you prefer. Pi's terminal rendering is also custom built. The PyTui package implements differential rendering with 3 strategies to minimize screen updates, and uses the CSI 2026 protocol for atomic updates that eliminate flicker. It has its own component system with containers, editors, text rendering markdown display, image support, and select lists. The coding agent's TUI is built entirely on this framework. For tool handling, Pi ships with 7 built-in tools: read, bash, edit, write, grep, find, and ls. That's a deliberately minimal set. The bash tool supports optional Docker sandboxing and real-time streaming output. The edit tool uses unified diff format. All tools validate their arguments with AJV before execution and support parallel execution by default, meaning multiple tool calls from the LLM run concurrently rather than one at a time. Now, let's compare these two directly on the dimensions that matter most. Provider support. Both support over 20 providers and work with any OpenAI-compatible API. OpenCode uses the Versal AI SDK, which means it inherits new provider support as that ecosystem grows. Pi built its own PyI library, which gives it more control but requires manual integration of new providers. In practice, both cover all the major providers you're likely to use. The agent model, OpenCode ships with multiple specialized agents and lets you switch between them with a single key press. Pi ships with one agent and says if you want sub-agents, build them with extensions or spawn separate instances. If you want specialized modes out of the box, OpenCode wins here. If you'd rather build your own agent topology, Pi gives you the tools to do it. OpenCode uses SQLite, Pi uses JSON-L files. SQLite gives you transactional integrity and efficient querying. JSON-L gives you human-readable files you can inspect with cat or grep, and Pi's tree structure within a single file is elegant. Both support session branching and forking. Pi's tree navigation interface is particularly well designed for exploring conversation history. OpenCode has a comprehensive built-in system with approval dialogues per file rules and persistent permission memory. Pi has no permission system in its core and expects extensions to handle this. If you want guardrails immediately, OpenCode is the safer choice. If you run in containers or want full control over your security model, Pi's approach gives you more flexibility. MCP support. OpenCode has full MCP support with OAuth, multiple transports, and automatic tool registration. Pi explicitly rejects MCP in its core in favor of skills, which are CLI tools documented with READMEs. Mario Zechner wrote a blog post arguing that MCP adds complexity where a simple CLI tool with a README accomplishes the same goal. If your workflow already depends on MCP servers, OpenCode is the clear choice. If you prefer the Unix philosophy of small composable tools, Pi's approach might resonate more. Code intelligence. OpenCode has built-in LSP integration that gives the AI model access to type information, definitions, and references. Pi does not include LSP in its core. This gives OpenCode a meaningful edge for working in strongly typed languages where type context improves the AI's understanding. The terminal interface. Both have sophisticated custom TUI implementations, but built differently. OpenCode uses solid.js with the OpenCode framework. Pi uses its own Pi2e framework with differential rendering. Both look great and feel responsive. OpenCode additionally offers Atari-based desktop app and a web console. Pi is terminal only, though it offers a web components library that developers can embed in their own applications. Both use JSON-based configuration with project and global levels. OpenCode uses JSON-C, which is JSON with comments, a nice quality of life touch. Pi uses standard JSON. Both support extensive customization of models, tools, and behavior. OpenCode's configuration is more complex because there's more to configure. Pi's is simpler because there's less built-in surface area. So which one should you choose? Here are the questions to ask yourself. You want a tool that works fully featured out of the box, or do you prefer to assemble your own workflow? If you want to install a coding agent and have everything working in 5 minutes with permissions, multiple agents, MCP, LSP, and a polished experience, OpenCode is designed for that. If you want a minimal core that you customize exactly to your needs and you're comfortable writing TypeScript extensions, Pi is built for you. How important is MCP to your workflow? If you already use MCP servers or plan to, OpenCode supports them natively. Pi deliberately does not, favoring simpler CLI-based integrations. Do you work primarily in strongly typed languages? OpenCode's built-in LSP support gives the AI model richer code understanding, which matters most for TypeScript, Go, Rust, and similar languages. If you work mostly in Python or dynamically typed languages, this advantage is smaller. Do you want a desktop app or web interface? OpenCode offers both alongside the terminal. Pi is terminal only and proud of it. How do you feel about trust and sandboxing? If you want the agent to ask before doing anything dangerous, OpenCode's permission system handles this out of the box. If you'd rather run the entire agent in a Docker container and let it do whatever it wants inside that sandbox, Pi's no permissions approach pairs well with container-based workflows. Are you a power user who wants to customize everything? Pi's extension system is remarkably powerful. You can modify virtually every aspect of the agent's behavior, from tool execution to session management to the TUI itself. OpenCode has a plugin system too, but it's more focused on specific hooks rather than full behavioral override. Here's the honest bottom line. OpenCode is the more mature, more feature-complete product today. It gives you more out of the box, it integrates with more external systems, and it has a lower barrier to entry. For most developers who want an open-source AI coding agent, OpenCode is the safer bet. Pi is the more interesting design. Its aggressive minimalism and extension-first philosophy make it uniquely adaptable. If you're the kind of developer who customizes your NeoVim config for weeks before writing any code, if you want an agent that works exactly the way you think it should, Pi rewards the investment, and its session tree navigation is genuinely best in class. Both projects are MIT licensed, both are actively maintained, and both support the same broad set of LLM providers. You can try both in an afternoon. The code is on GitHub, and neither requires a subscription to get started. Install them, run them on the same codebase, and see which one clicks with how you work. That's the only comparison that actually matters.